Hello everyone. So in today's class, we will be discussing about transaction. My name is Dr. Ayushi Prakash. I'm working as a professor at Ajay Kumar Garg Engineering College. So in this lecture, dealing with the transaction and as we have already discussed about the basic concept of transaction, basically in today's class, we will be discussing about the serializability. So for a revision, we can see here transactions means a unit of program execution that access and possibly updates various data item. So any single logical unit of work, we can say a transaction. And again, we can see here that we do have a transaction, an example of transaction here where we are transferring amount 50 from account A to account B. So here we can see there is a transaction and we do have two data item A and B. A, we are deducting 50 INR 50 and transferring it to account B. So we are executing here a simple transaction. So there is a problem in transaction when we are working in a serial schedule, as we have discussed in our earlier class, that in serial schedule, there are two main issues. The first one is lesser number of throughput, and the second one is not proper utilization of resources. So we do have some problems. To overcome this problem, we have to discuss today about the serializability. So basic concept of serializability, you can say why basic assumption, you can say each transaction preserves database consistency. So here also we have to ensure the consistency. Serial execution of set of transactions always preserves database consistency. But in case of concurrent schedule, what we are dealing in serializability, there is a chance to lose the consistency. So to ensure the consistency, we have to deal with the serializability. Serializability is like we can see here two types of serializability we will be discussing here: conflict serializability and view serializability. So serializability, as in like we can see here in the example, suppose that we have two transactions. Suppose that we have two transactions, T1, T2 and T3. If we are working in a serial schedule, then there must be an order of execution of T1, T2 and T3. The order can be T1 first executes after the completion of T1, T2 will execute after the completion of T2, T3, or it can be T2, T1, T3, or it can be T1, T2, T3, T2, T3, T1. It can be in different order, but in serial schedule, before the completion of the first one which has already started, we cannot jump to the next transaction. But in concurrent schedule, we are doing interleaving. Interleaving of operations means when we are executing, suppose that of one transaction, we can swap to the next transaction, and when we are doing here we can see here in a clear mode. So we can see here what we are talking about. T1, T2. Suppose that there are two transactions and here we want to do work in a concurrent, not in a serial mode, in a concurrent mode. Then in this case, we can read any data amount A and then can switch to read of T2, then read B, write A. So here in concurrent schedule, we can interleaving of operations are allowed. It means we can swap from one transaction to another without the completion of the first one. So we can consider it as in a good way that by this we can provide the proper utilization of resources, and by this way we can provide the most important thing, that is the throughput. But at the same time, consistency is important. So we need to preserve the consistency. So we have to see the serializability. But because we are interleaving from here to there and again here to here, we can see there we may face some problems when we are interleaving. I mean, like in concurrent execution, interleaving is allowed, but this can create some problems. Like we can see two operations on the same data object can conflict if at least one of them is right. Anomalies can arise in concurrent transaction if two transactions T1 and T2 conflict with each other. Those anomalies can leave the database in an inconsistent mode. So what are the anomalies we need to see here? The first one is lost update problem, dirty read problems, the second one, and the unrepeatable read problem. So every these anomalies we have to provide the solution. I mean, like we must tackle all these problems to preserve the consistency. Now, what is the lost update problem? We can discuss here. Then dirty read problem, and then we can see unrepeatable read problem. In lost update problem, so because two operations on the same data object can conflict. So the problem is if one operation is right, if both operations on the same data item and both are read, then there is no chance of conflict. So if the problem is when at least one of them is right. So lost update problem, first we need to discuss about the lost update problem. Lost update problem, a transaction overwrites the value of data item which has been modified by another transaction. We can see with example. So there are two transactions, T1 and T2. We can see here. T1 is reading the data item A and again updating the data item A by debiting the amount with 100. So earlier it was 1000, A was 1000. After deducting 100, now it is 900. Now T2 is reading the value again 1000. Why? Because T1 has not updated the database. So it has already deducted 100, but it has not updated by write it. So again T2, when T2 is reading account A, so it gives the value 1000. So this is what we call lost update problem, where the initial value was 1000 and 100, T1 deducted 100 by account A, but due to it is not updated the value here in T1, we can see again T2 can also see the same amount, initial value 1000. So this is the lost update problem. The value of A written by T2 is overwritten by T1, whereas serial execution of T1 then T2 or T2 then T1 would have given the final value of A is 700. So this is what we call a lost update problem or write-write conflict. Then a dirty read problem, when we are dealing with serializability, or we can say in a concurrent execution environment, we can also see these problems. We are facing these problems when we are dealing with the concurrent environment. When a transaction fails after updating a data item and before the data item is changed back to its original value, another transaction reads the updated value. Let's suppose we do have two transactions and the initial value of amount A is 2000 and amount B is 1000. Now we can see with example. So here we can see T1 and T2 are two transactions where the initial amount of A was 2000. Now after deducting 100 from account A, the value is 1900 and it is updated in as 1900 with write operation. Now when T2 will read it the value will be 1900. After reading the updated value that is updated by T1, it will be deducting 1% of A from A. So it will be 2090 and again updating the value. The value is updated by 2090. Again reading the account B, that was 1000, and 1% of B is deducted by account B. Now the value deducted, not it is credited. I mean, like 1% of B added in account B, so it is 1100 now, and updated the value 1100. So what is the problem? Here we can see abhi tak to sab theek chal raha hai. Now what is the problem? Now A is 2090 and B is 1100. T1 is reading the value B, that is 1100, and it is working. In between, this T1 fails and it is rolled back. In any way, we can see here that T2 is reading the value that is already updated by T1, and then T2 has, let's suppose T2 is committed this transaction, and then without the completion of T1, and now T1 is failed and returned back to the safety state, and again it will start its working. So in this case, the problem we can see here that T2 has already read the value of A from T1 and thereafter change it, but T1 is rolled back and it acquires the new value of A. So this problem is called dirty read problem, where the updated value read by any transaction, and that transaction on which the second transaction is dependent is rolled back and provide some another value to the database. So this is the problem of dirty read. Now, unrepeatable read problem. A transaction tries to read the value of data item twice, and another transaction update the data item in between the two reads of the first transaction. As a result, the first transaction reads varied values of the same data item during its execution. Let's suppose here we can see we do have two transactions, T1 and T2. T1 reads some amount A and T2 reads then amount A. So here in T1 we are doing read operation on account A, and T2 read operation on account A. After that, T2 is updating the account A and update the database by writing operation. Again, T1 is reading the value of account A. So here the updated value shown by the transaction. So it will be, now if earlier it was 500, here we do it 600. So it will be reading 600. So we can see here in between two read operation, there is a write operation of T2 which can create a problem. That is what we call unrepeatable read problem. As a result, the first transaction reads different value of the same data item during its execution. So this is called unrepeatable read problem. Also, we will see it as read-write conflict. So what is the reason of all these anomaly, and how can we ensure that our transactions are free from these anomalies? So we have to ensure by seeing the conflict instructions. So first we need to know what are the conflict instructions. We are knowing, हमें ये समझ में आ रहा है why we are reading about this conflict instruction, because to avoid all these anomalies. So we can interleave from one transaction to another without completion of the first one, and also we can avoid the anomalies. So conflicting instructions, we should know, it is very important. Instruction II and IJ of transaction Ti and Tj. Suppose that we are going to take an example in which we have taken two transactions Ti and Tj, where II and IJ are two instructions. So when we can say conflict, so conflict if and only if there exists some item Q accessed by both II and IJ, and at least one of these instructions wrote Q. So there are two conditions we are seeing: same data item and at least one write. When transaction is working in a mode where both transactions are working, suppose that transaction Ti and Tj having instruction II and IJ, and both working on the same data item queue. If the data items are different, there won't be an issue. If they are working on the same data item, and if there are both instructions are read, there won't be any issue. If there is any one write, at least if it is write, if it is write read or read write. So one write, everywhere we seeing at least one write, so we can consider it as a conflict. Conflict, it is very clear if and only if there are they're working on this same data item, and at least one of these instruction is write on that data item. So we can see here, if the instruction I is read on the data item queue, instruction ij is again read on the same data item, then do not conflict. Why not conflict? Because they are working on the same data item, but there is no write operation here. So we can see it is not showing any conflict. Now, in the case 2, we can see here I is read on the same data item, write on the same data item, but conflict will be here. The reason behind, there is one write here in both the operations. Again, we can see here one write in both operations. Again, we can see here here we have two writes, but because we do have at least one write, we can say it is conflict. So we can see a conflict between II and IJ forces a logical temporal order between them. If II and IJ are consecutive in a schedule, they do not conflict. Their results would remain the same even if they have been interchanged in the schedule. So what is conflict serializability? Before knowing conflict serializability, it is very clear that we are knowing about conflict and the conflict instructions. Now coming to the conflict serializability, because conflict instructions, pair of conflict instructions are very important in doing conflict, in getting conflict serializability or conflict equivalent. So if a schedule S can be transformed in a schedule S dash by a series of swap of non-conflicting instruction, we say that S and S dash are conflict equivalent. Let's suppose we do have any S schedule and S dash schedule. So here we do have T1 and T2, two transactions. Here also we do have T1 and T2. And in these two, S and S dash will be considered as a conflict equivalent. When it will be considered as a conflict equivalent? When it can be transformed. When, suppose that if it is a conflict, it is a conflict schedule and it can be transformed. How can it be transformed? With a series of swaps of only non-conflicting instruction. So we can create conflict equivalent. We say that the schedule S is conflict serializable if it is conflict equivalent to a serial schedule. So here we can see conflict serializable. So for serializability, first we know that we should know about the serializability. When we are working on concurrent execution in a mode where all transactions are working in a parallel mode in a concurrent environment, and we are switching from one transaction to another transaction, I mean like interleaving from one transaction before completion. So what serializability provide? In a schedule, there must be an order. In a serial schedule, there must be the completion. T2 must start after the completion of T1. But in serializability, we can interleave from one to another transaction. But there is a rule that serializability, any serializability, if I'm talking about conflict serializability, there must be a conflict equivalent to serial schedule. यहाँ पे swapping allowed है, but after swapping, we can provide any of at least one equivalent, conflict equivalent that is equivalent to serial schedule. So it is very important here in terms of serializability. So conflict serializability, it is very clear that for conflict serializability, we need to know about the conflict equivalent. Why? Because getting the conflict, if it is conflict equivalent to a serial schedule, then only we can say it is conflict serializable. For conflict serializable, we know about the conflict equivalent, and for conflict equivalent, it is the series of swaps of non-conflict instruction. So we have already discussed about the conflicting instructions. So those who are not conflicting, that those who are not working on the same data item and there is no any write in between two operations, those who are swapping, we can say it is conflicting instructions. And if they are non-conflicting, so they can swaps and we can get the conflict equivalent. So with this example, we can see conflict serializability. Here we can see schedule 3 can be transformed into schedule 6, a serial schedule where T2 follows T1 by series of swaps of non-conflicting instruction. Therefore, we can say schedule 3 is conflict serializable. Let's take an example, that is in the first schedule 3. Let's suppose here S is equal to 3 and S dash is equal to 6. So what was the rule? That we have to find the conflict equivalent of S with this serial schedule S dash, right? So this is the transaction where we are swapping from one transaction to another, and again from here to here, and again from here. It means interleaving is allowed here. We can see before the completion of one, T2 started. Before the completion of T2, again T1 started. So this is a concurrent mode of schedule. Now, if we are able to again provide equivalent schedule, serial schedule, equivalent to serial schedule, then we can say yes, it is conflict. So now we have to check it. We have done read A, then write A. So like here we have swapped. What if we can see here read A, write A? So before, because this is read operation and this is write on operation A, so we can transform it in a serial schedule read A, write A. Before doing this, because it is working on different item, so we can do it earlier. यहाँ पे A पे काम हो रहा है, read हो रहा है A पे, then write A पे हो रहा है, फिर यहाँ पे A पे हो रहा है T2 ने, तो यहाँ सीरियल अगर हम इसको करना चाहें, we can work it before T2 के A वाले से, क्योंकि यहाँ डेटा कंफ्लिक्ट में डेटा आइटम अगर डिफरेंट हो तो we can swap. इसलिए आपने इसको ऊपर लिख लिया. So now we can see read A, write A, then read B, write B, and then here also we can see B. So we can do it read A, write B, and then read B, write B. So we can do it we can provide it a equivalent serial mode of a schedule. So we can say it is conflict serializable. Now here we can see one schedule. Now we have to find, let's suppose, as to are we able to provide the serial schedule? Let's see. These are two transactions, T3 and T4. Q is a data item where we are reading Q, and then T4 writing. Are we able to provide a serial schedule? Can we do it as like T3, T4, T3, T4? Are we able to do it like read Q, write Q, write Q? Can we do this? No. Why? Because if we want to change this pair, so in between this same data item and one write operation, we cannot change it. Again, here we can see two write operation on the same data item. So we cannot do it upward. So we cannot change it in this way. So we can say, no, we are not able to provide this equivalent serial schedule. So it is not conflict serializability. So for today, I believe conflict serializability is all clear. So in next class, we will be discussing about view serializability and the questions of conflict serializability, in which we will be seeing the precedence graph by which we can easily see and test the conflict serializability. Thank you.